Chapter 8, Section 2, Two-Sample t-test. The previous video provided you with the overview of t-test. This section will cover details of how to implement t-test using two samples. Let's examine whether the sample means of two samples are equivalent. A two-sample t-test is a method to test whether the population means of two groups are equal or not. We need to use different methods depending on whether the groups are dependent or independent. Two groups are dependent when collecting data from each participant twice and comparing the population means for the same set of persons. Dependent groups are also called as matched or paired groups. On the other hand, two groups are independent when we collect the data from each participant only once and compare the data between different persons. First, let's consider a t-test for dependent groups. It is called a dependent sample t-test or paired sample t-test. In the dependent sample t-test, we use the mean difference between the paired sample for hypothesis testing. That is, we determine whether the mean difference between the two sets of observation is zero. So, the null hypothesis is that the mean difference between the paired samples is zero. A dependent sample t-test is commonly applied when we want to examine some intervention's effect. Suppose you are a human resource manager and implemented an organizational development intervention to improve the employee motivation. And we collect the sample data on employee motivation before and after the intervention. We want to know whether our intervention had desirable effect on the employee motivation. The first step of hypothesis testing is specifying the null and alternative hypothesis. A null hypothesis of a dependent sample t-test should know that the mean difference between the paired samples is zero. So, the null hypothesis is that the average motivation level is the same before and after the intervention. And the alternative hypothesis is that the average motivation level is different between before and after the intervention. The significance level is set to 0.05, and we use t-value as the test statistic. Then, find p-value from the t-value and compare it with the significance level. For simplicity, suppose the survey result is this small dataset. It shows 5 employees' motivation score before and after the intervention. Using this data, we should calculate the test statistic. Here, it is a t-value. We can calculate the t-value by this formula. In this case, our focus is the difference in motivation between before and after the intervention. So, the sample mean in this case is the average difference of motivation between before and after the intervention. So, it is 0.8. As for the population mean, in this case, we want to see whether the population mean is 0 or not. So here, we set the population mean, mu, to 0. The unbiased variance is computed for the motivation difference between before and after the intervention. So it is 1.7. And the sample size is 5. By plugging in these values, we can get the t-value, 1.372. As we use the t-value as a test statistic, we use the t-distribution table here. The sample size is 5, and thus the degree of freedom is 4. And we set the significance level to 0.05. So, let's see the intersection of the degree of freedom of 4 and the significance level of 0.05. The t-value at the intersection is 2.776. Its absolute value is larger than that of the t-value computed from the data, 1.372. So, we cannot reject a null hypothesis. We should conclude that the intervention did not have a significant effect on employees' motivation level. Next, let's consider a t-test for independent groups. In an independent sample t-test, we use the mean difference between the independent samples for hypothesis testing. So, the null hypothesis is that the mean difference between the independent samples is 0. Let's consider an example. Suppose you're a human resource manager and we collect a sample data on employee motivation from technology team and sales team. We want to know whether the average motivation differs between these groups. First, let's specify the null and alternative hypothesis. A null hypothesis of an independent sample t-test should know that the mean difference between the independent samples is 0. So, the null hypothesis is that the average motivation level is the same between tech and sales. And the alternative hypothesis is that the average motivation level is different between these two groups. The significance level is set to 0.05. And we use t-value as the test statistic. In an independent sample t-test, we need to use a test statistic that reflects the sample's independence. We should use the t-value, but it is more complicated than in a case of a dependent sample t-test. The x bar 1, mu 1, n 1 are the first group's sample mean, population mean, and sample size, respectively. The x bar 2, mu 2, n 2 are the second group's sample mean, population mean, and sample size. This formula is very complex, but we can make it a little simpler. When the null hypothesis is correct, the population means of each sample are equivalent. So, mu1 minus mu2 equals 0. So, we can rewrite the formula in this way. The formula is still complex, but you only need to understand that this formula represents the difference in sample mean between two groups, considering sample sizes and variance. The denominator contains unbiased variance. Here, the unbiased variance is a pooled variance, which combines the variances of the two groups. It can be computed in this way. For simplicity, suppose the survey result is this small dataset. It shows 5 employees' motivation score from the two departments. First, we compute each group's sample mean and variance. Then, we compute the pooled variance using the formula. Next, using the values of the sample means, the pooled variance, and the sample sizes, we compute the t-value. It is minus 1.089. As the final step, let's determine whether we can reject a null hypothesis or not. The sample size is 5, and thus the degree of freedom is 4. And we set the significance level to 0.05. So, let's see the intersection of the degree of freedom of 4 and the significance level of 0.05. The t-value at the intersection is 2.776. Its absolute value is larger than that of the t-value specified in the previous step, 1.089. So, we cannot reject a null hypothesis. Thank you for watching. Please thumbs up and subscribe to my channel.